Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we solved a question number 3 related with the exercise number 3.2 relevant with the topic of equation of tangent and normal line to the given curve at a specific point. In today's video, I am going to solve the next question, question number 4 related with the same exercise number 3.2 related with chapter number 3 higher order derivative and application FSC part 2 mathematics. In the previous chapter number 2, we solved differentiation. So there we will solve the given function per first time derivative dy by dx. And the previous exercise number 3.1, we solved different type of function per first time derivative, second time derivative, per third time derivative, means higher order derivative. But the Taylor series expansion is used for the derivative up to nth term. So that's why we use the Taylor series expansion for the functions. So that is that show that first four terms in the Taylor series expansion of f of x is equal to tangent x about x is equal to pi by 4 are 1 plus 2 into x minus pi by 4 plus 2 into x minus pi by 4 whole square plus 8 by 3 into x minus pi by 4 whole cube. This is first term, this is second, this is third, and this is fourth. That is that show that f of x is equal to tangent x at x is equal to pi by 4 will give us these four value. Remember solution for the Taylor series expansion, we have the formula that f of x is equal to f of x naught plus x minus x naught f prime of x naught and plus x minus x naught whole square divided by 2 factorial f double prime of x naught plus x minus x naught whole cube divided by 3 factorial f triple prime of x naught. They tells about first four values. So these are the first four term, 1, 2nd, 3rd, and 4th. We cannot go up to n. So after this, f of x is actually equal to the tangent x. Our f of x, let's suppose this is the formula. This is equation number first. Our f of x is equal to tangent x. So if we replace x with x naught, so it becomes f of x naught will be equal to this actually x naught. So our f of x naught will be tangent into x naught, and x naught is pi by 4. So tangent pi by 4 will then equal to 1. So our f of x naught is equal to 1. Now after this, our x naught is actually equal to pi by 4. Now over here we have f prime of x naught. So we will differentiate the given f of x naught. So it becomes f of x naught will be equal to derivative of tangent x is secant square x. So over here we have f of x naught which is a secant square x, but the value of x is pi by 4. So our f of pi by 4 will be equal to secant pi by 4 is actually secant 45 degree. Secant 45 degree is under root 2, and under root 2 square will give us a value 2. After this, again differentiate f prime of x naught. So it will give us f of double prime of x naught will be equal to, take the derivative of 2 secant square x, so it will give us 2 into secant square x tangent x. So first we will use generalized power rule. Again we will differentiate secant x will give us secant x tangent x. Now at pi by 4 it becomes f double prime of pi by 4 will give us 2 into secant pi by 4 is actually under root 2, and under root 2 whole square will give us a value 2, and tangent pi by 4 gives us 1. So the required f double prime of pi by 4 is equal to 4. Now after this, for the triple time derivative, x naught triple prime of x naught will be 2 into, we will use a product rule. So it becomes secant square x, and tangent x derivative is secant square x plus tangent x, and derivative of secant square x is 2 secant square x and tangent x. 2 secant square x and tangent x, and tangent x will give us tangent square x. Now at pi by 4 it will give us f pi by 4 it will give us 2 into secant pi by 4 gives us under root 2 whole square gives us just 2 dot. This will also give us 2 plus it will give us 1 because tangent pi by 4 is 1 dot 2 into it will give us 2 multiply 2 will give us 4. So the result will be 2 into 2 gives us 4. 4 plus 4, it will give us a value 8. 8 multiplied 2 will give us 16. This is f triple prime of pi by 4. Now putting the values in the given Taylor series expansion, it will give us a value f of x. So f of x is actually equal to the tangent pi by 4. will be equal to f of x naught, the first term. The first term is actually equal to 1 plus x minus x naught. X naught is actually pi by 4, so x minus pi by 4 into f prime of x naught. F prime of x naught is secant square x whose value is just 2. So it will give us x minus x naught. It will f prime of x naught is actually equal to 2 plus x minus x naught whole square. X naught is pi by 4, so pi by 4 whole square divided by 2 factorial. 2 factorial is actually equal to 2. Multiply f double prime of x naught. F double prime of x naught gives us a value 4. And after this plus x minus x naught. So x minus x naught is pi by 4 whole cube divided by 3 factorial is equal to 3.2.1. It will give us just 6. And f triple prime of x naught is actually equal to 16. So by simplification it will give us 1 plus 2 into x minus pi 4. It becomes 2 into x minus pi by 4. And plus 4 is cancelled out with 2, it gives us 2 into x minus pi by 4 whole square. And over here 16 and 6, these both are the factor of 2. So by dividing both with 2, it will give us 8 into x minus pi by 4 whole cube. And dividing 6 by 2, it will give us a value 3. So we show that f of x is equal to a tangent x at pi by 4 gives us 1 plus 2 into x minus pi by 4 plus 2 into x minus pi by 4 whole square plus 8 by 3 into x minus pi by 4 whole cube. This is the required proof for the part number A for the question number 4 Taylor series expansion. Now move to the next part number B of question number 4. Show that first term in the Taylor series expansion of f of x is equal to root x about x is equal to 4 are these 4 terms. We will prove that f of x is equal to root x and the x is equal to 4 will give us this 4 value. So using Taylor series expansion formula that f of x is equal to f of x naught plus x minus x naught f prime of x naught plus x minus x naught whole square by 2 factorial f double prime of x naught plus x minus x naught whole cube divided by 3 factorial and f triple prime of x naught. Now our given function is f of x is equal to root x. So at x is equal to 4, let's suppose this is actually our x naught. So at x naught it becomes f of 4, it will give us under root of 4. So under root of 4 is actually equal to 2. So f of 4 is equal to 2. Now after this we are going to differentiate f prime of x naught. So we differentiate the given function. So f prime of x naught, you know that under root x derivative is 1 over 2 into under root of x naught. So putting the value of x naught, it becomes 1 over 2 into x naught is 4. So under root 4 is actually equal to 2. So it will give us a value 1 over 4. This is f prime of x naught. Again differentiate for the second time derivative. So f prime of x naught will be, we can write it 1 over 2 x power minus 1 over 2. So for the derivative it becomes 1 over 2, the power will comes to the front, so it becomes minus 1 over 2, and subtract 1 in the power, it becomes x power minus 3 by 2. Minus 3 by 2. Differentiation of the inner function is 1. So by putting the value of x is equal to 4, so it becomes minus 1 over 4. It will comes to the denominator, it becomes x root x. X root x. The power is negative 3 by 2. So by moving to the denominator, the power becomes x root x. It can be written as x power 3 by 2. So x is 4 and under root 4 is 2. So 4 multiplied 2 will give us 8. So the value is minus 1 by 32. This is f double prime of x naught. Now for the third time derivative, our f triple prime of x naught will be equal to our derivative is minus 1 over 4 and x power minus 3 by 2. X power minus 3 by 2. Now for the third time derivative, power will come to the front. Minus 1 over 4 multiply minus 3 by 2. Again subtract 1 in the power. It becomes x power minus 5 by 2. So it becomes minus gives us plus 3 by 4 multiply 2 gives us 8. And this will come to the denominator. It becomes x square and under the root of x. So 3 by 8. X is actually 4. So 4 square will give us a value 16. And multiply under root 4 is actually equal to 2. So 2 multiply 8 gives us 16, and 16 multiply 16 gives us 2 pi over 6. So 3 divided by 2 pi over 6. This is actually f triple prime of x naught. Now putting the values, it becomes Our f of x is actually root x, which is equal to f of x naught. F of x naught gives us a value 2. So it becomes 2 plus f prime of x naught is actually 1 over 4 into x minus x naught, so minus x naught. X naught is actually equal to 4. And after this, we have plus f double prime of x naught. F double prime of x naught is minus 1 over 32. So minus 1 over 32 into x minus x naught. So x naught is 4 whole square divided by 2 factorial. So 2 factorial is actually equal to 2. And after this plus f triple prime of x naught is 3 by 2 pi o 6. 3 by 2 pi o 6 into x minus x naught. So our x naught is 4, so 4 cube divided by 3 factorial is actually equal to 6. Now again for further simplification, and the root x will be equal to 2 plus 1 over 4 into x minus 4. And over here 32 will multiply with 2. It will give us minus 1 over 6 4 into x minus 4 whole square. 3 will cancel out with 6, so it will give us 1, and over here it will give us 2. That 2 will multiply with 2 5 6, it will give us plus 1 over 5 1 2 into x minus 4 whole cube. So these are the required 4 terms that we are going to show that 2 plus 1 over 4 x minus 4 minus 1 over 64 x minus 4 whole square plus 1 over 5 2 x minus 4 whole cube. So this is the required proof for the part number B. Now move to the last part number C of Taylor series expansion. Taylor series expansion and maclaurin series expansion, these are very important phenomena and very important topic for the board point of view. Part number C tells that show that the first 4 term in the Taylor series expansion of f of x is equal to x plus e raised to the power x about x is equal to 1, or it gives us this series. So taking the given function f of x is equal to x plus e raised to the power x. So replace x with x naught, so it becomes f of x naught will be equal to x naught plus e raised to the power x naught. Our x is equal to 1, so f of our 1 will be, so it gives us x naught will be 1, and plus e power, it becomes e power 1, which gives us e. So f of 1 is equal to 1 plus e. Now differentiate the given function, so it becomes f prime of x naught. You know that derivative of x is 1, and plus derivative of e power x is e power x. Derivative of e power x is derivative of e power x, it will give us a value e power x. Now at x is equal to 1, it will give us f prime of 1. It will give us 1 plus e raised to the power x is 1, so it will give us 1 plus e. Now for further derivative, for second time derivative, so f double prime of x naught will be derivative of 1 is 0, and derivative of e power x is just e power x. So if x is equal to 1, it will give us f double prime of x naught will be equal to e. It will give us just e. Now for a triple time derivative, f triple prime of x naught will be derivative of e power x is again e power x. So if x is equal to 1, it will give us f triple prime of 1. It will give us just e. Now by putting the values, it becomes we have the formula f of x is equal to f of x naught plus x minus x naught, f of single prime of x plus x minus x naught whole square by 2 factorial, and f double prime of x and plus x minus x naught whole cube by 3 factorial, and f triple prime of x, and goes on. Now f of x is actually equal to 1 plus x plus e raised to the power x will be equal to f of x naught. So it gives us 1 plus e. So 1 plus e into x, 1 plus e into x plus x minus x naught. So our x can be written as x minus x naught is actually equal to 1, and f prime of x, f prime of x, it gives us 1 plus e. So it becomes 1 plus e. So 1 x minus 1 plus e, and after this plus it will give us x minus x naught whole square by 2 factorial. So x minus 1 whole 2 factorial can be written as 2 into f double prime of x. So f double prime of x is actually equal to e, and plus x minus x whole cube. So x minus 1 whole cube, 3 factorial gives us 6, and multiply by f triple prime of x is actually equal to just e. So after this, it is very easy just by taking out e common. So it becomes 1 plus e into x plus take out e common. So it becomes x minus 1 whole square by 2. 2 factorial, it can be written as 2 factorial plus over here take out e common. So it becomes x minus 1 whole cube. 6 can be written as 3 factorial, and goes on. X will give us x minus 1 whole power 4, and after this 4 factorial and goes this is actually the required Taylor series expansion. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification about upcoming exercise and upcoming question about second year mathematics. Thank you.